Assalamu alaikum. My name is Ahmed Kamran, and today me with my group members Mohammad Rohan and Ali Sher are going to talk about the subgraph isomorphism that is discussed by Oberoi and his given code. So first off, let's talk about understanding the input data set of football matches. Uh, so basically, to give some background information on the topic, basically data composition is where football matches data is represented as temporal passing networks. So where the nodes are the players and edges are the passes between them. So basically, edges signify more than just passes. They are basically properties like direction, frequency, and success rate. So this slide talks about what basically is temporal representation. So basically, what they do is they aggregate all passes into one network, and this is very bad in comparison to in comparison to temporal graphs. This is because uh, the time sequence between them is lost. So all of the passes are aggregated into one single snapshot. The benefit of temporal passes is that they preserve the time, so you know exactly when the pass was made. So this slide talks about the strategy of segregating matches. Matches are divided into smaller intervals, capturing the state of the passing network during each time frame. So first off, let's talk about rolling time windows. Window length is often of 5 minutes and is chosen to define each snapshot. Step duration is basically determines the overlap between consecutive snapshots, ensuring smooth transitions. And temporal graph generation is basically that every snapshot passes within the time defined window and modeled as edges between player nodes. Overlapping windows help capture continuous patterns, enabling deeper analysis of strategy. The advantages of this is basically, first of all, let's talk about granularity, which is that it breaks the matches into finer temporal segments, aiding in understanding moment to moment changes. So this provides a better understanding and clarity to basically what goes on in the match. And secondly, it reduces the noise that is made by the overlapping passes. So it isolates individual match dynamics without mixing data from different games. So this slide talks about understanding Oberoi's code and changes. Basically, he developed a dynamic subgraph isomorphism setting which focuses on identifying matching substructures in dynamic graphs. And secondly, he used a snapshot-based approach where each temporal graph snapshot is compared to predefined patterns. What this means is that he took every single snapshot between time frames and compared them to each other. So, for example, recurring passing strategies. So, let's talk about the original algorithm. There are multiple features of the original algorithm. First off, it ensures that node and edge mappings respect temporal order. This is on the contrary to static graphs. It basically hones itself to the temporal order. Secondly, it incorporates pruning strategies to optimize the search space for matches. And then possession based focus is basically what it does is that it adapts to analyze football possession phases by treating each possession as a unique dynamic pattern. And secondly, it segments passes to capture interactions within specific possession.
Assalamu alaikum. I will be talking about the graphic profiles. Basically, what do these profiles do? That these extract small packets of data, which are basically the substructures or the recurring trees between these graphs. And what basically these are like chains, or these are like a triangle of meshes. Now, what do? They actually have a very important task, and these are used to summarize the tendencies and the behaviors of the different players, and these can be used to map a certain stylistic changes inside the players. Now, uh, entropy integration, basically entropy means the disorder or the disorganization of different particles. So in entropy different integration, we basically measure the variable. Assalamu alaikum. Now, I will be talking a little bit about entropy integration. Now, entropy means the disorganization and the declustering of data, which is basically the discrement and the spreading of data from a certain cluster. Now, what do we do in entropy integration is that we measure the variability in patterns among different snapshots. We see the patterns and we see the snapshots, and we identify the patterns among them, and we determine what are their variable factors. Now, when the entropy is high, it means that the graph is diverse and there is unpredictable play, which means that the styles are more unique, and we cannot do something to and we cannot do much to generalize the playing styles. However, when the entropy is low, this means that they are more recurring, and more recurring and more repeating subtrees within the graph. So this indicates more predictable strategies. Now, efficiency improvements, we can improve the efficiency of this algorithm by, especially when we have large data sets, by streamlining the nodes and matching these processes and leveraging the pre-computed feasibility sets. But basically, we can try different algorithms and we can take different ways and we can compromise on certain aspects to enhance other aspects. Like, for example, we can compromise on memory to enhance speed, or it can also work the other way around. Where we have low speed, we can compromise on the memory.
Assalamu alaikum. My name is Mohammed Rohan. So first of all, the raw data includes player IDs, timestamps, time and start time, like past sequences. Okay, then the data is cleaned to remove inaccuracies. This step is included in pre-processing. So, what do you think about data is cleaned to remove inaccuracies? Inaccuracies means the when the passes from one player to another player to another player, uh, the at that instant moment when the snapshot will take that accurate this means that accuracy. Graph snapshots are constructed based on the time intervals or possession phases. Temporal graphs. Temporal graphs are basically linked with the nodes and edges visualized dynamically across time intervals, highlighted key passes or clusters, basically the groups of the frequent player interactions. Entropy trends linked with the chart fluctuations and passing in predictability during a match. So the graphlet frequency is the bar graph showing the dominance of the specific patterns such as triangular or central hubs. Then there are 3 points that indicate the significance: interpretation, high entropy indicate diverse, dynamic passing, complicating defensive efforts, and the low entropy reflects repetitive strategies, making the team predictable. Implementation workflow. Actually, the current issue is there is no clear indicator to separate matches within the dataset. The dataset might involve multiple matches, but the separation is not specified in the data. So, suggested approach to separate match. First of all, we divide the match into temporal snapshots or position intervals. Graph construction includes nodes and edges are dynamically added based on the passes within each snapshot. Subgraph analysis identify graphlets and calculate their frequency. Then the entropy evaluation measure unpredictability across snapshots. The suggested approach to separate match is to get the unique match ID, and if match ID is not unique, then we calculate the match ID in a way to separate the matches. But this technique is not separating all the matches, all the 14 to 14 match, but introduce a match ID column. First of all, we will talk about visualization of the code. Visualization includes, first of all, this is the output of the code without the code implementation of the without a code implementation to separate the matches. First of all, there is a data of team one, and then the data of the team two. Then the distribution of passes received by a player is uh, shown by you, and distribution of passes sent by the player. We have both distributions, data received and data sent. Then the baseline. We also show the accuracy in all and accuracy in two. Then this is the output of the data, output of the code. Now the we have all the prediction times and prediction values sent to closer plus penalty for opposite team player. And if matches are recorded sequentially with a consistent time gap, you could use time start or time end to create a match ID. For instance, if the time difference between entries is large enough, for example, a break between two matches, we can assign new match IDs, time-based separation. If there is a break between matches, for example, large gaps in time start or end time, you can define a threshold time gap and use that to separate the matches. And this is I will show you the code of for matches separation on the behalf of match ID. This is the code. This is the function of separate matches, and this is the place where we call the function, and we print the match ID by a loop. This is the loop going from a different match ID, receiver ID, and send ID, and also there is a match ID.
Now I'll be talking about the key passing patterns and the comparisons. Now, the first pattern is the graphlet-based comparison, as we discussed earlier about the graphlets. Now, considering two teams, Team A and Team B. Now, uh, Team A basically in it passing is centralized around the key, the keys which are basically the playmakers. Now they are forming structures which are clusters, basically hub-like structures. And the Team B, they are dispersed passing, which is a more discrete and scattered form of a passing pattern. Now, as I discussed earlier, if it is unpredictable, it means it has a higher entropy. So Team B has a higher entropy, and Team A has a lower entropy. Now, when the entropy is higher, we have a greater adaptability. And when there is a greater adaptability, there is a reduced amount in the predictability for the opponents. Now, there is a comparison to the Borges basketball study. Now, Borges highlighted similar findings in the case of basketball. Now, when the passings had high entropy, they were correlated with the better team performance and more unpredictable move set. And what does this do? This basically provides rich insights into the adaptability as compared to static model when we are discussing the context of temporal graphs. Now, additional study that inspired this project is that the Burgess and the use of temporal passing networks, these were used to capture the dynamic team behavior. Now, the last thing which we can understand from all of this project is the key takeaways, which are basically the entropy-based measures effectively evaluate adaptability and unpredictability in team strategies, as high entropy means more unpredictable and a more discrete form graph, whereas low entropy means a more clustered form graph and more predictable. Now, temporal models, these reveal strategic changes in in the static aggregation space, such as shift in passing hubs or roles during critical phases of play. Now, this study validated the importance of capturing temporal dimensions, reinforcing the project's focus on entropy and the graphlet analysis, which we discussed in detail. Now, conclusion. I would like to end this with a few points. Oberoi and his team's snapshot model, which it provided basically a powerful solution for detecting temporary consistent subgraph patterns in dynamic graphs. What this basically did is that it addressed the challenges of representation, efficiency, and temporal efficiency. Temporal accuracy. This advancement offers significant value in in the domains where the sequence of changes is critical. The current dataset does not have an explicit technique due to the separate matches. However, the time-based approach to add a match ID for each pass event, which also checks the time gap between the events, is more is basically a good idea to optimize the whole flow of the algorithm. And implementing this logic will allow us to group the events by match and analyze them separately. And I think that will be all. Thank you for listening.